So this is definitely a science talk. It's possibly not an ACCESS talk. The contents of it can be transferred to ACCESS, and there's a couple of plots from ACCESS. It's mostly from CSM2, but I stood up in front of the CSM2 people and told them about ACCESS. So I'm sure it all balances out. But the science point is that I'm trying to understand when the rest of the world impacts ENSO and the Pacific and how much it does. If you have questions at any point along the way, just butt in and interrupt me. So hopefully we're all aware that ENSO is a thing in the Pacific Ocean. And we've got all these diagrams that say if you've got the Pacific Ocean sea surface temperatures doing this, that's going to have such and such an effect on the rest of the world. So during an El Nino, Australia should have less rain. Or during an El Nino, Australia is kind of warmer, this bit's drier, and you have these patterns across the world. And those kind of are the impacts from the tropical Pacific on the rest of the world. And it's less clear what's happening in the other direction. So presumably, because the world's all interconnected, these different basins will also feed back onto ENSO and influence ENSO. But it's not clear which ones dominate or how strong any of them are. So if we just zoom in on one particular example in the Atlantic, I've got 3 papers that show completely different conclusions about how important the Atlantic is. So this is a GRL paper that came out a couple of months ago and says all of the correlations between the Pacific and the Atlantic are purely because the Pacific or El Niños are influencing the Atlantic, and there is no correlation in the other direction. And so even so, you might get a lagged correlation between the Atlantic and the Pacific. That's purely statistical, and there's no physical relationship between the Atlantic and the Pacific where the Atlantic is driving the Pacific. And then there's another one that says if you nudge the Atlantic, you get very slight improvements in Nino 3-4 predictive skill. So you get from like 0.83 to 0.87 or something, which is almost no improvement, but this technically shows the Atlantic's doing something. And then there's an ACCESS study that shows if you prescribe tropical Atlantic sea surface temperatures, then you fix the CM2 periodicity. So instead of this weird biennial ENSO, you get a much more reasonable ENSO periodicity. And that says the Atlantic is very important for ENSO evolution. So just within the impact of one particular basin, we've got a large spread of viewpoints on how important it is from different techniques and different models, probably different times of year. And then if you try and take a step back and bring everything together, all of the different basins have this kind of mess. So what hope have you got to try and say, all right, which bits are relevant to ENSO at any point? And I'd like to try and say, okay, what is important for each of these basins? How much do each of these different ocean basins or extratropics in the same basin impact ENSO? And then dig into maybe why have we got these differences in previous studies? So how are these impacts from different basins dependent on the models that you use or the lead time for making a forecast or the seasonality of the link between the two of them? And there's a reason no one's done this before. It's primarily because if you try and do anything with statistics, it gets complicated. So you can see that the Atlantic is very clearly correlated with the Pacific, but it's not clear which one's doing the driving there or how much the Atlantic's driving the Pacific or the Pacific's driving the Atlantic. And the same thing with other regions. And then you can get around this by trying to use pacemakers, where you prescribe sea surface temperature or something in an individual basin. And then you can look at one particular scenario or one particular thing because they're too expensive to run a whole batch of just because. So we get these individual studies that look at, so I saw one that said, all right, what if we look at this particular event in the Indian Ocean? How did that event in the Indian Ocean as opposed to a climatology influence ENSO? And that's a reasonably good, very tiny piece of the puzzle, but when you want to look at the whole puzzle and try and bring everything together. And so I need to use a different technique. The technique I'm using is called model analogs. It's been championed by NOAA in the last few years, and it can get around both of these problems. And I think I introduced it at the ACCESS-NRI workshop earlier in the year, but we're going to go through it again. So supposing we start with some sea surface temperatures in the equatorial Pacific in July, The normal way of making any forecast would be to initialize a model with those temperatures and then run it forwards in time. Now, instead, what I do is I take that observation and I take a great big library of possible states. So in this case, look, some ACCESS pictures. It's the ACCESS ESM 1.5 pre-industrial control. And I can say that in the ACCESS pre-industrial control, maybe this year looks kind of similar to my observations, and maybe these two also kind of similar. So instead of initializing the model again, we're just looking through these model runs that already exist for times that look similar to what we would normally initialize with. And if you do that for the full ACCESS pre-industrial control, you might get these 9 Julys that look the closest to the July that we're trying to match in 2023. And then your forecast is as simple as just following those through time in the control run that you already have data from. So we go into August and follow those through to maybe January and average them again. And that's the forecast from the analogs. And this forecast is almost as good as initializing again. So at the top, we have an analog forecast from the paper that first started using these analogs for ENSO, and the bottom is an initialized forecast. And the skill is fairly similar in both the plots. Maybe the analogs do a little bit better exactly along the equator, and the initialization does a bit better over here. But in general, the analogs seem like a fairly equivalent forecasting tool. And then if we come back to those two problems that stopped us looking at my question earlier, that we can't, the stats are hard and the pacemakers are expensive, we can address both of those with model analogs, because it's not a statistical tool, it's a forecasting following things through time. So it's similar to initializing the forecast, but it's much, much cheaper because you're just reading in data from previous runs. So I can run these things in a couple of hours on my laptop as opposed to needing to take compute time and run them extensively. And another bonus point is that you're looking through a control simulation. So sometimes in a pacemaker, you might prescribe an additional C-surface temperature or an anomaly to see what happens, and that may or may not be something that could happen. Whereas with the analogs, whatever you're trying to do is just looking at the influences of different basins from what's a reasonable normal thing to do. So I'm building off the paper that initially showed you could use these things for ENSO. And then I'm picking analogs using sea surface temperature and sea surface height in CSM2 for the moment, but there's a couple of ACCESS plots coming later. And then I'm weighting that sea surface temperature and sea surface height by the lagged correlation with NINO 3.4, because that's what I'm trying to predict. So for example, you could find that at 12 months ahead, or the 12 months lagged correlation with NINO 3.4, of the sea surface temperature in the Pacific look kind of like this. So you're going to want to weight this section fairly highly, and this section, even though it's negative, also highly. So I'm actually weighting by the absolute values instead of the positives and negatives. And then you can pick out analogs based on the bits that look similar in these regions that have high, particularly strong positive or strong negative correlations. And you get forecast skill that looks something like this. So we've got lead time increasing vertically and the seasonality across the x-axis. And that shows that at 0 months lead time, you've got fairly good skill. By the time you hit 12 months lead time, the skill's gotten a lot worse. And you've also got a spring predictability barrier running down here. And I think that's a pretty common ENSO forecast skill pattern. But the reason we can use these is to look at different basics. Oh, and there's an outline. So previously I was picking out analogs based on just the correlations in the tropical Pacific, but you could also pick out analogs based on the region in the tropical Pacific and in the tropical Atlantic, and then also weighting these by correlation. Now, if the Atlantic is purely driven by ENSO, this means that anything you do trying to pick matching the Atlantic as well as the Pacific will give you exactly the same forecast skill as just using the Pacific, because the Atlantic wouldn't be giving any extra information. Whereas if the Atlantic is driving ENSO in some way, then picking analogs based on both Pacific and Atlantic is going to give you a slightly increased skill. And this is when the Atlantic improves skill and by how much. And the black dots are a very rough back of the envelope measure of significance. So don't take it as gospel, but it's roughly when the colors should be trusted or not. And that shows that shorter than 6 months lead time, it doesn't really matter whether you use just the Pacific or the Atlantic as well. The Pacific forecasts do fine and the Atlantic doesn't improve much. But after 6 months, you get some improvement in your forecast skill from including the Atlantic Ocean. And I'll just put up the Pacific skill as well. And this gray line contours when the Pacific skill has a R² greater than 0.5. And you can see that when the skill in the using just the Pacific for analogs isn't great, the Atlantic is helpful. So the Atlantic improves the skill if the Pacific was producing poor skill on its own, but only then, which kind of makes sense. It says that in this time period when Pacific only skill is good, that's the times when ENSO is growing and kind of imprinting on the rest of the world. But the times when ENSO is not growing so strongly, then influences from the Atlantic Ocean might be relevant. And we see something very similar using the Indian Ocean. So I was hoping you get some kind of cool seasonality where the Indian is important in some months, the Atlantic is important in others. But I think mostly what you see is that both of them are relevant in these regions when the Pacific is poor. So in January and February, after 6 months lead, over here, which kind of makes sense. And then previously, all of the things I've shown have been using perfect models. So I've also tried the same thing, but predicting from observations. And then you don't get any of those patterns that I was expecting. So either my theory is completely wrong, or the model's representation of what's happening in different basins and how they're relevant doesn't actually map to the real world. And if anyone has any suggestions for why this is the case or how they're different, that would be great. But it seems like you get maybe a decrease in skill if you use the Indian Ocean initializing in like November or December, whereas in the perfect model, it's an improvement. So maybe the perfect model says it's an improvement and says it's relevant, but CSM2 thinks that the Indian Ocean is relevant in the wrong way or something. Then I also checked ACCESS. Now, ACCESS is an interesting shaped improvement, or just skill pattern. So there seems to be that anything that predicts April has much lower skill than the month before or after. So I guess that's a really strong spring predictability barrier. And then I've shifted this contour from 0.5 to 0.3 because it outlines that shape better. But I'm not sure which of the contours is the best one to use in general. Nonetheless, if you also include the Indian Ocean or the Atlantic Ocean, then you get improvements outside the contour. So at times when the Pacific Ocean skill was poor, or the skill from analogs selected using the Pacific, just the Pacific Ocean was kind of poor, then including extra information from the Atlantic or the Indian Ocean seems to improve things. So these are ideas that I have about how to explain this, but they're still very preliminary, and I would very much welcome any thoughts on what you see in the plots or what to look at next. And I had a summary slide, but I actually wanted to leave these plots up, so I got rid of it. That's all I've got.
Thanks, Jemma. Great talk. At the moment, you are using the PI control run to find the right months or the right pattern. Yeah. Does it matter that's the PI control run? I mean, would it be better to use more present day control run?
The present day control run is probably also fine. I haven't used it just out of habit because I just grabbed something quickly.
But general a control run is most appropriate for this type of analysis. You don't want
if you use something with historical changes, then you get changes in ENSO as well as the internal variability. Whereas if you use a control run, you've just got internal variability. So I think having a control, or wondering about using some of the really early parts of the ensemble, like the smiles from 1850 to 1950, would work. But once you have a climate change signal, it gets more complicated.
Yeah, I see. So you need a long control run for this type of analysis. Yeah. Okay, thank you. So opening it up to everyone else, I think Julie has her hand up.
Yeah, thanks, Gemma. Great talk. It was just a clarification. You may have said, but how are you defining ENSO? Is this NINO 3.4 or
I'm just trying to print NINO 3.4.
have you tried? It'd be just interesting to try using the SOI or some other
I
metric.
haven't tried SOI. When I was looking a few months back, it didn't seem to matter which ocean region you used. So NINO 3 or NINO 3.4. But I haven't tried the atmospheric ones and I haven't looked again recently. Is there any in particular you think might be different?
Well, I think the SOI would just be interesting since that's maybe where the teleconnections come from. And so
Yeah, okay.
interested in, you know, the impacts, then that it'd just be interesting to see how the SOI might differ.
Yeah.
Thanks.
Sebastian?
Hi, Jemma. Great talk. I might have missed it. I was just wondering how you pick the analogs. Is it by eye? Are you going through each year,
no.
or is it like you just look at the correlation to a?
It's RMS weighted by correlation.
Right. Okay. Cool. Thank you.
David, you got your hand up as well.
Yeah, thanks, Jemma. So I'm just curious. You showed your initialization, and I think you had a region between about 30 north and 30 south in the Pacific as your area of like finding the analog simulation, right? So I'm wondering if you're then looking at the influence of the Atlantic or the influence of the Indian, whether it would make sense to change your area where you're looking for the best correlation in a simulation. Instead of looking at the Pacific as defining your analog, could you actually just look at the Atlantic and the similarity index there and use that as the definition of, I mean, in terms of trying to match observations?
Yeah. So I don't think there's too much point using just the Atlantic because you would have the imprint of the Pacific. So by looking at the difference between the Pacific and the Atlantic, then you can see what the Atlantic adds. But the Atlantic is going to have some Pacific imprint and something of its own anyway. And then if you're making predictions from just it, and it's like hypothetically, if ENSO has this really strong imprint and does nothing the other direction, but it's like a perfect imprint on the Atlantic, then you would still get really good predictions using just the Atlantic, just because it's capturing that byproduct of ENSO, even though it's not driving it. Does that answer the question?
Yeah, I see what you're saying there. I was just wondering if you could somehow, I mean, because when you looked at the observational predictability, right, you got pretty poor outcomes in the Indian and not so great also in the Atlantic. Is that right? So
yeah.
Yeah, right.
Yeah.
So yeah, I mean, I was just wondering if there's some way you can change your definition of what's a good analog, whether that would be helpful here.
Yeah. You get the same thing if you try different regions in the Pacific. So I tried 10 north to 10 south instead of 30 north, 30 south. And yeah, I guess the whole reason I want to try different regions is to see which ones get you the best skill. So if there was a different analog definition that got much better skill, then that would tell us a lot about what's happening in the observations. But I guess I don't know what to try exactly.
Gabriel, you have your hand up as well.
Yes, I think that would be like more like a suggestion than really a question. I think that you, I think that you could have a look at the different ENSO flavors. So you could split that in between the Central and Eastern Pacific ENSO El Niños. Because I don't know, I was just thinking that most models are better in simulating, I think, that the Central Pacific El Nino, while they have some more issues when trying to simulate the Eastern Pacific El Nino. And that might be related to some interbased teleconnections as well. So
yeah, maybe.
Maybe if you split between the two types of ENSO, you may have a clear signal of the interbased teleconnection. I don't know. That's just
possibly. So I tried splitting into El Niños and La Niñas, and there just wasn't enough data points to get anything except noise. And then I want to look at some indices that look at different regions. Or I tried using Nino 4 instead of Nino 3.4. It doesn't make much difference, but I haven't tried splitting by different types, so I can try that.
Yeah, you can try to split that through the EOFs. So I think that's the clearest way of splitting both types of ENSO. Cool, thanks.
Okay.
Hey, thanks for the great talk, Jemma. I suppose my question is, so since you can do this with a PI control run, so I suppose it opens up the possibility of doing it with lots of different models.
Yes.
On the ACCESS 1.5.
Which is what I would like to do next.
Yeah, okay, so you haven't kind of ventured down that way. I was kind of curious whether you'd done any initial...
No, I ran the ACCESS one last night.
Okay.
And yes, I definitely want to look at how different models represent things. And I'm hoping that the differences in when things are useful will be dependent on the ENSO structure, because that seems to be the case so far. But it would be very interesting to see how different models react and what that says about how the models consider various basins to be useful or not.
Yeah, I'd be curious just whether it changes a great deal or not. Thank you.
Julie, you got another question?
Yeah, just I guess going back to this, the fact it's not consistent in the observations, it might be good to go look at the historical, like Tilo was discussing, to see how much of it is due to the changing over that period versus...
Yeah, okay.
Some of it might be coming from that difference in the warming trend in the historical. And then I also wondered, Steve Yeager at the workshop, or in his paper at least, was showing how you can get this Southern Ocean leading the tropical Pacific.
Yeah.
In their decadal predictions, and so would it be useful to look at, say, ACCESS predictions or in this context at the hindcast, I'm wondering.
So I want to run a box like this with improvement from using the Southern Ocean as well. I just haven't done it yet. What ACCESS hindcasts are you referring to? I'm not sure I'm familiar with them.
So maybe Unpa can speak to them, but there's a hindcast from, I think, 1980, is it, Unpa? We can't hear you, you're muted.
Yeah, from 1981 to 2018.
Yeah, so you could look at the lead zero. It's basically like looking at a reanalysis if you just take the forecast, seasonal prediction forecast. So, and then, but then you can also, I guess, because they've predictions, you can look at basins, so I guess Steve Yeager can see that the Southern Ocean changes first and then the tropical Pacific changes. So you can kind of get some of that kind of lag. So I'm not sure if this works for analogs.
The lags are complicated because ENSO is so strongly autocorrelated, which is what's produced such a huge argument about the Atlantic. So it looks like the Atlantic leads the Pacific.
Yeah, but I'm wondering if you could use your monoanalog technique in some of these forecast models that might help.
How long are they?
So ACCESS, I think, is 6-month forecast, but it's from 1980 to 2014.
Yeah, maybe. I suspect that it's not a long enough run to use analogs.
And then
you've really got to go through all the climate states.
30 members.
Okay, maybe. Yeah. Thanks for the suggestion. I will look into it.
Okay. If there are no more questions, Unpa.
Yeah, can I ask a quick question while I'm unmuted?
Sure.
Thank you for the talk. And so you selected 9 analogs, like 9 members, looking very similar to this year's July El Nino patterns. So have you looked at the second year? So what's following those El Nino patterns?
You get barely any forecast skill after the second year.
Oh.
So the analogs are good for short term, and then they seem to lose fidelity at longer times.
So it can't tell us whether La Nina will happen next year or the second
I don't think
El
you can
Nino.
do so with much confidence. And it's also, I guess, all the CSM2 ones are going to have that strong biennial ENSO, so I wouldn't trust them anyway.
Thank you.